How many people watch D-News? We say it at the end of every video, and we mean it. Thank you so much for watching. We do episodes on D-News, for those that don't know, about all sorts of different things. People have questions about things, and we try and answer those using science. We talk about earwax and why we have it. We talk about how many dimensions there are in the universe, and there are a lot. Way more than 3 or 4. There's like 11. We talk about all sorts of things. Sex robots, bees, dinosaurs. Sex robots. I mean, come on. Not even a little cheer for that? Okay. But we also talk about things like, for example, why we like watching things in a theater. Why do we like getting tickets to opening night of Star Wars? Like, why do we do that? What's the point? We answered that too. Welcome to D-News After Dark, D-Newsers. You're sitting here surrounded by other people and you are instantly affected by their presence. We are social animals. We crave group activity. For example, we are all more likely to laugh if other people are laughing too. This is why sitcoms love studio audiences. It tickles our primitive group nature. Collective emotions are a social exclamation point, and they love company. Think about it. What's brown and sticky? A stick. Why would you laugh at that? Because science. Functional MRI scans of people's brains done at University College London found that when people heard sounds like laughing or screaming or retching, the premotor cortical region of their brain lit up. When we hear sounds associated with a nonverbal expression, our brain preps us to mimic our fellow humans. I know you might be thinking, that's crap, I don't See, you just did it. When we feel fear around us, when we feel stressed or feel happy, our behavior becomes contagious. A German study found when people started clapping, we all feel compelled to clap along. That brings us to tonight. We're all here now. We're all together. We're ready to clap and squirm and chuckle and have our collective minds blown. Tonight, you're doing something we have never done. You're watching D-News in a room of other people who are also watching D-News. This is crazy. So welcome, everybody, to D-News After Dark. Let's get to tonight, because you didn't just come here to listen to me jabber about subscribing and D-News and watch videos. You already do that, hopefully. Crystal Dilworth, Dr. Crystal Dilworth, is a molecular neuroscientist. She's very smart. She works for Techno on Al Jazeera. She dances, she does choreography, she works in a lab occasionally as well, taking pictures of all sorts of cool cells, which she'll show you. And she has the best shoes in the biz, for sure. True story, check them out. So without further ado, Dr. Crystal Dilworth and how brains can get all glowy.
All right, well, they gave me a microphone, and I get to stand up here and just talk to you about the stuff that I get really excited about when it comes to science. But our theme is After Dark, so I'm going to talk to you a little bit about science and dark and really cool things that I enjoy about light. So science is sometimes actually described, the process of science is sometimes described as trying to find light in the darkness. I mean, we look for one really specific blip amongst thousands of very similar blips, and we look for a single equation that can resolve a conflict. But if you're a fluorescence microscopist like me, you are actually looking for a single quanta of light, a photon, where no one has seen a photon before. And you know, light's really awesome. Because of it, we developed our visual systems to help us navigate the world around us. We see color, visual art. These things bring me a lot of joy, but light is also really complex. It comes to us as particles and as waves. And a beautiful rainbow has hidden within it these qualities and colors that we can't even see. So light is complicated. And when you break it down into its component parts, what you see are different wavelengths, which are different energy levels, and we see this as color, which is pretty cool. But not just seeing it, plants, they need it for food. So this is your average basil plant. It's green. I'm sure you guys all know that it's green because it has chlorophyll in it. And chlorophyll is that molecule that you all learned about that captures light and combines it with water and then makes food for the plant. But chlorophyll doesn't actually collect all light. It only collects certain wavelengths of light. It collects blue light and red light. And that's why we see green, because it reflects all of the wavelengths that it doesn't absorb. So the question is, could you grow plants in the absence of light if you only expose them to red and blue? And the answer is yes. So this is a tomato plant that I took a picture of. It's being grown indoors without natural light and only being exposed to blue and red light using LEDs, which is pretty cool. I mean, just think about it. Like, if we could have high quality produce grown literally anywhere, like, what would that mean? I mean, you could even, like, grow food in space. Oh, wait, we did that. Oh, yay. So this is lettuce that's being grown under those conditions with only blue and red light for the astronauts on the International Space Station. And so you and I could be eating food that's grown like this, you know, when we're like on our way to Mars, that really long trip to visit the grandkids for Thanksgiving, like in a few years, you know? Okay, look. I know it's no potato, but science has to start somewhere, so incremental changes, and we'll get there. We'll get to a high energy like potato. So besides color and light, like, what other ways does biology use light? Well, biology can actually create its own light, which is really cool. So these are dinoflagellates. I love them. When they're not creating red tides to make everybody sick, they're making these beautiful blue-green, like, kind of fairy lights in the ocean. They do this in response to changes in pH in the water and also kind of as a defense mechanism. There's so many other organisms in nature that, like, make their own light. So you think of, like, fireflies and you think of glowworms. Biology has actually independently evolved bioluminescence, which is what this is called, like 40 times the nature of Earth's history. So nature really, really appreciates light for communication, especially. But I really want to talk to you about that. I want to talk to you about my favorite bioluminescent organism, my hero, really, the jellyfish. I love the jellyfish because the green fluorescent protein that this jellyfish makes is why I'm a doctor now. And so I am very thankful for this jellyfish. And so are 3 other guys that won the Nobel Prize for isolating and purifying the protein that this jellyfish makes. What can we do with green fluorescent protein? Well, green fluorescent protein has actually revolutionized several forms of science, but I'm just going to talk to you about molecular biology today. So isolation and manipulation of the fluorescent protein that is found in this jellyfish has actually led to a spectrum of different colors of protein. So we can use these, like, biological highlighters to kind of paint different aspects of biological systems so they stand out to us and we can study them. So let me explain a little bit of what I mean. These are really cool. These are endothelial cells from cow artery. And they don't usually look this colorful, but we've used 3 different fluorescent proteins to paint different parts of the cell. The blue spot in the middle is the nucleus, and the red and green are structural features that allow us to see just how big the cell is, what shape it is, if it's healthy, and how it is interacting with its neighbors. So that's really cool, but we can go even bigger. This is your brain on fluorescence. Okay, not your brain. This is a genetically modified mouse brain whose neurons are expressing fluorescent protein. But we can use pictures like this to actually see connections between different brain regions. And we can verify that connections exist that we had only hypothesized before. This gives us a lot of additional information about how the brain functions and also why we behave the way we are. But the really cool thing is once you get a picture like this, you can zoom in and you can take a look at individual cells that are within that brain. This is a picture that I took myself. These are embryonic mouse neurons, and they're expressing GFP, green fluorescent protein, everywhere. And I stained them because first I wanted to see if I had successfully kept them alive. And also I wanted to see what kind of neurons they were and whether or not they were forming connections with their friends. And you can see that they really are, and it's really cool. This is one of the first pictures I took, and I was like, okay, I'm not gonna fail grad school, that's good. And so eventually I moved on to looking at different types of cells. So you can see this is a different color and it's not homogeneous, right? We see different colors within these cells. And what that's telling me is where the protein is. So I've linked the fluorescent protein to a protein that I wanted to study. By the way, for anyone that's interested, I studied nicotinic acetylcholine receptors. You don't need to know that, you just need to know that that's the reason that some of you are addicted to nicotine. So the yellow spots are where more of the protein is, and the blue spots are where less of the protein is. This distribution changes when I add a nicotine solution, and that tells me a little bit about the function of the protein I'm trying to study. Now on to the cool video. This is a kidney. You are taking a journey into a kidney that has been fluorescently labeled so that you can see the different structures. This is a mouse kidney. You can see that you're going all the way through, so all of those little circles are actually vasculature. And you'll see that when we stack all of the images that we take on top of each other, we can get a 3D model of an intact organ. This allows us to look inside this organ, this kidney, and ask questions like, is it healthy? If the animal was diseased, what was going wrong? And this actually can give us a lot of information about how to approach human diseases in the future. You see that? That's pretty cool, right? That's a mouse kidney. Like, that's a whole mouse kidney right there. So for instance, if the mouse had a genetic mutation that would give it a kidney disease, we would be able to see structural differences in an image like this, which is really cool. And this is also how science that happens at the bench gets translated to the science that you encounter when you go to the doctor. So let me tell you a little bit about how fluorescence is helping our lives now. There's a new approach to cancer surgery that I want to tell you about. You're a surgeon. You have a human patient open on the table, and you need to remove the cancer cells. Unfortunately, they all look the same. Where do you cut? Right now, the standard of care is ultrasound or radioactivity, neither of which are very high resolution. So what if we could selectively label the cells with light so that we could see which ones need to come out and which ones don't? Well, we did it first in a mouse. You can see a little bit of a red outline of a mouse. Those green cells are tumor cells. And so this light is telling the surgeon, these are the bad cells, these are the ones that need to come out, thus reducing the amount of good tissue that the surgeon removes. This is being done on human patients. I actually got a chance to watch this in action. It's incredible. So what this helps with is reducing the good tissue that is extracted, so you're only taking the bad tissue, and it reduces the number of secondary surgeries. So if your surgeon didn't get all of the cancer cells the first time, sometimes they have to go back in and do it a second time. And so this is just one really clear example of how a protein in a jellyfish could be affecting your life in the really near future. So all I really want you guys to take away from what I'm sharing with you today is fluorescence is really cool, and fluorescent cells are really cool, but also that you can take a look at different things from different scales and different perspectives, and everything looks just a little different. That's it. Thank you.
Amy Shira Teitel is a space historian. That is a job that I did not know existed until I met her, because I think she invented it. She has her own show. It's called Vintage Space. It's on YouTube as well, and it's a great show. She live tweets Apollo missions. It's like the nerdiest and most amazing thing ever. She will, for weeks and weeks, be like, Trace, I can't talk to you right now. I have to look at all of the mission logs and write minute per minute what the astronauts were saying to each other so I can tweet it. She loves also new space. She worked on the New Horizons mission for a little while. Who loves Pluto? She was one of the first people to see the new images of Pluto. She is super cool. And she's here to talk to us a little bit about the far side of the moon.
We don't really think about it necessarily, but we only ever see one face of the moon. And it's this face, and that's because the moon is tidally locked to the Earth. So I'm going to get Julian and Julia to come up here to demonstrate what tidally locking looks like. So Julia, you will be our Earth, and Julian, you will be the moon. So Julia, I'm going to get you to spin on the spot a little bit, and Julian, you're going to go around Julia and just stare her down like a little bit of a creeper. Keep spinning, Julia, keep spinning. So, so this is the essence of tidally locking. The moon spins around its axis once every time it goes around the Earth, so the result is that we only see one face of the moon, kind of like the creeper that is always staring you down when you're just trying to get your jam on at the club. Thank you, lovely hosts. So tidally locking can be explained by the giant impact that created the moon. So the theory goes, the Coles Notes version, which is like the Canadian version of Spark Notes, Canada. The early Earth was molten and spun quite quickly and was smashed into by a giant Mars-sized, theoretical Mars-sized body, sometimes called Theia, which blasted a whole whack of material out into an orbit around the Earth. And that material coalesced into what we now know as the moon, and through some nifty gravitational dealings in the early solar system, it became tidally locked. But we're going to forget about the moon formation stuff because that's not what I really want to talk about because it's less fun than pretty pictures. So let's pretend for a second, because I really like the 1950s. Let's pretend for a second that it is October 3rd of 1957, and a handful of people, a few scientists, a few engineers, but mainly a lot of crazies, really want to go to the moon, but no one knows anything about the moon. Nothing has ever left the atmosphere, and no one knows anything at all about the moon beyond what we can see. Then on October 4th, the Soviet Union launches Sputnik, and the world changes. This 184-pound ball effectively opened up this whole new arena to exploration, and everybody wants a piece of it. The more engineers, more scientists, all the crazies, and the military. The military is like dead set on not only exploring the moon, but setting up bases on the moon, militarizing cislunar space. Like, it was weird, guys. The stuff they wanted to do was nuts. So unsurprisingly, lunar missions were the first to get off the ground. There were some Earth orbital satellites, but really, lunar missions were the first ones to leave the Earth. The US Air Force started launching the Able/Pioneer program in August of 1958, and the Soviet Union followed up with the Luna program in September. And there were a lot of failures, as you might expect, in the early months of space exploration. A lot of satellites failed to reach orbit, and a few got on overzealous rockets and ended up orbiting the sun. Not what you want. So then, on October 4th of 1959, 2 years to the day after launching Sputnik, the Soviet Union launched Luna 3, which had a camera on board, as well as a full image processing system and a radio transmitter to send the images back to the Earth. 3 days after it left the Earth, the photocell detected light bouncing off the far side of the moon, and it turned on the camera. And for 40 minutes, it took pictures and gave us history's first ever look at the far side of the moon. And it's not great. There's a lot of noise, there's not a lot to see, and when you clean up the pictures, it really doesn't get that much better. But the lack of stuff on the moon's far side in these first images is actually really interesting, because even these terrible pictures show us a very different face of the moon. It doesn't have the giant mare, those big dark areas that we see on the near side that are the result of volcanic eruptions filling in craters. We see a much more uniform, much more heavily cratered face. And these pictures also showed us that we needed more pictures to really understand what was going on the far side. And of course, there were more missions and more programs, like Zond. Zond was another Soviet series of unmanned interplanetary probes spun off from a planned, the L-1 program, which was designed to send actually Soviet cosmonauts to the moon. It was kind of their version of Apollo that really didn't get very far. And Zond 3 was a test flight designed to see whether or not Soviet communications equipment could actually work in the distance between the Earth and Mars. And it also had a camera on board. It launched on July 18th of 1965, and it reached the moon after just 33 hours. And when it photographed the moon's far side, It looked specifically at the areas that Luna 3 had not seen. And for the first time, these images actually show distinct features on the far side of the moon. So we can actually see mountain ranges, mare, granted it's much smaller than the ones we see on the near side, and craters. So we've been talking a lot about Soviet missions, and that's in large part, because they really did take the lead in the early space age for years. But NASA wasn't out of the game, okay? This is 1965. By this time, NASA was really starting to pull ahead of the Soviet Union and was firmly on the way to the moon with Apollo. But if NASA was going to get astronauts to the moon, it had to know where to put them, because you don't just go and hope. So understanding the moon and figuring out where to go and how to pick a safe and interesting landing spot was the goal of the Lunar Orbiter program. The Apollo landing sites were, of course, going to be on the near the Earth-facing side of the moon because NASA wanted to talk to the astronauts. Radio waves can't go through the moon. But because these early surveying missions were in orbit, they caught these beautifully high-resolution images of the moon's far side. These actually resolve features up to 6 feet across, some of these images from this program. So the far side of the moon is increasingly revealed through these amazing images. This is 67. A little less than 2 years later, Apollo 11 lands on the moon, and the space race arguably ends. But there were obviously still missions going to and beyond our natural satellite, like more Zond missions. Remember Zond? Zond 8 flew past the moon on October 24th of 1970 on a circumlunar flight, to the moon, not past, on a circumlunar flight with turtles on board, flew around the moon, returned to the Earth for a safe splashdown 3 days later. And among the images it brought back is one of my all-time favorite images of the moon, is this one. That is not a great picture. It's pretty unclear, pretty modeled, but I love it because it reminds me a lot of the plaster moon from Georges Méliès's 1902 movie Le Voyage dans la Lune, or A Trip to the Moon. It was a movie and a book that inspired, remember those crazies from 1957 that wanted to go to the moon? A lot of them were inspired by this movie and by this book, so I've always loved that picture from Zond 8. So by the time Zond 8 went to the moon in 1970, 5 Apollo missions had already gone past the far side of the moon, Apollos 8, 10, 11, 12, 13. And they captured some incredible images of the moon's far side, as did the last 4 missions to go past the moon, Apollos 14 through 17. And they returned some incredible images like this one from Apollo 16 that I've always really loved. And it's a view that only 24 people have ever seen with their own eyes, which I think is kind of incredible. So this is all well and good, but why does the far side of the moon look so different than the near side? So it's not the case that the Earth actually shields the moon from impacts. There is the idea that meteorites that would be going towards the moon to impact it are shielded and burn up harmlessly in our atmosphere as opposed to hitting the moon. That's not what happens. What actually happens is that the moon's crust isn't actually uniformly thick. The near side's crust is thinner, which means that when the moon was young and newly formed, more volcanoes were able to erupt on the near side, and they filled in the early impact craters. And this continued through the period, the so-called late heavy bombardment period, where everything in the inner solar system from Mercury to Mars was really battered by a lot of bodies. So all of this lava was filling in the impact craters on the near side, giving us these big dark mare regions, whereas the far side didn't. So it has this kind of uniform heavy cratering that's really strikingly different for the opposite side of a body. We don't really see this kind of difference. Think about how familiar our solar system is. Like Trace said, I was in the room at the Applied Physics Lab in Maryland this summer on, I think it was like 6 a.m. on July 14th, when we got the first high-resolution image of Pluto down. And for me, that was a huge moment because I realized that it was the last time we would ever see something new in the solar system ever again. Because we have pictures of the planets, we have pictures of the moons. Even the ones that suck are amazing because we can see things billions of miles away. Nothing is unknown in the solar system. But less than 50 years ago, our own satellite was a mystery to us. And even though the first ever images from the far side of the moon are horrible and noisy and don't really look like much and don't tell you anything, it's amazing to think that we have only known any detail about the thing that is the closest to our own home. Is 50 years old, and it's the far side of the moon. It's the first mystery that we were ever able to uncover. And that's why space history is so great to me. And speaking of space history, I can't not do this. My book came out today. So I'm going to shamelessly plug my book, which is actually only out in the UK today. The US release date is January 12th. It's all about a prehistory, the story of spaceflight before NASA. It looks at the, from 1930 to 1958, it looks at the development of rockets and space planes and rocket engines and spacecraft and human factors and bureaucracy and all the things you need to make a space agency. NASA wasn't created in a vacuum, guys. All of the things that you needed to create a space agency that could function and go to the moon with this existed before we had a space agency. And the story of those pieces is very narrative, very accessible. There's no math. There's very little science. It's all story. It's really, if you guys are so inclined, that's my plug. Thank you.
Natalia Reagan is another one of our friends of DNews, and she's an anthropologist and a primatologist. So it means she studies primates, obviously, but she also studies culture. She studies us, and she does this in a variety of different ways. She does comedy. I think that's a great way to study culture. She also goes to Burning Man, another great way to study culture. She has her own podcast called Talking, which is literally just about poop. Natalia Reagan is here, and she's going to talk to us a little bit about something that I think is ever present in the media right now, but is also something that's super important when we're talking about humans.
How's everyone doing? Woohoo! I love this city. San Francisco is one of my favorite places in the world. And normally I talk about comedic things like boobs, butts, balls, and Bigfoot, but when I was asked to talk tonight, I thought, you know what, this is an excellent opportunity to look at something that is rife with controversy and is very important and relevant at this time and should be looked at through a scientific lens. Tonight I'm going to talk to you about race. So, it's 2015, right? We are truly living in interesting times. Now, if you're like me, you might be really miffed that you did not get that hoverboard yesterday. However, we got something even better this year. The Supreme Court ruled on June 26, 2015, that marriage, regardless of gender, sexuality, is legal in not just one state, but all 50 states. Even the White House celebrated. This was a coup for human rights. This was a push towards tolerance in the United States, and this was a day, I think, I'm not alone by saying I was proud to be an American. However, this is great, right? We're becoming a more tolerant country. However, you see images like this being from Ferguson, October, in response to the shooting death of Mike Brown, and you think, really? Is the United States come to this? Are we as tolerant as we think? And you see images like this. This is a Million Man March in 2015 that harkens back images like this from 1963, 52 years ago, a march on Washington led by Dr. Martin Luther King Jr., where he gave his I Have a Dream speech. And with the deaths of Eric Garner, Sandra Bland, 12-year-old Tamir Rice, 9 parishioners in a South Carolina church killed while the Confederate flag still flew above the State House, it's no surprise that our battle cry right now, our most important activist movement, is Black Lives Matter. Right? But that makes you question, why in 2015 are we still battling this issue? Well, some people are still living in the dark in terms of understanding race. They are using science to champion racist agendas. And as a scientist, I see this is an opportunity, and we have an ethical responsibility as scientists to stand up and tell the public what we know about race to hopefully promote positive social change and also tolerance. And I don't know if science can erase racism, but hopefully it can help diminish it and at least have us look at race through a different lens. Now, I want to talk to you a little bit about the human brain. We like to put things in boxes. We like to compartmentalize. A lot of times we think in twos, binomial oppositions. You're either right or you're wrong. You're either male or female. We're getting better about that, by the way. You're either a Republican or a Democrat. And then it comes to the age-old question, pancakes or waffles, to which the correct response is always tacos. Right? But what about race? Can we really just lump groups of people into boxes? Race, in terms of biology, is not real. There is no biological basis to racial classifications. You cannot draw a line between the groups that are commonly called races using science. So stop. But what I'm saying is race is not real as far as a biological construct. It is real as a social construct. Humans created this idea of race, and therefore, we have the power and the opportunity, and it seems like right now we might actually want to deconstruct this idea and reconstruct it in a more positive, tolerant light. Yay, right? Race isn't all bad. A lot of people identify with their race group and they're proud of it. It's a sense of pride, heritage, and that's wonderful. It's only when people use science to pit one another against each other and backing up their racist claims with science that I get miffed. So we're going to talk about ways that we've sort of misunderstood race in the past and why it's wrong. So we're going to talk about biology. Some people say there's a lot of differences biologically between race groups. Well, I'm going to tell you something. They're wrong. There's only 0.1% genetic variation within our species. We are far more similar than different. And in fact, this pales in comparison to our closest genetic relatives, the chimpanzees, which have anywhere between 0.3 and 0.7% variation within their species. And you would think that the variation between groups would be most seen between those of European and African descent, but it's actually of those of African descent, and that's called the founder effect. It's the idea that basically when you start from a small population, we evolved 200,000 years ago, a drop in the geological time bucket, if you think about it. We're a very young species. We evolved in a very small population, and over time, as we spread out through time and space, variation decreased. It's about this idea of its clines, which is slow, continuous change over time and space. That's why you see a picture like this, and you'll see it's hard to basically draw a line between these different ethnic groups, rather than clades, which is speciation, and basically branches in the evolutionary tree. We've determined that there's not much genetic variation within our species, so we're pretty much more similar than different. However, if you look around this room, and there's a lot of really good-looking people here, just saying, you're going to see we don't all look alike. We're very different. So why is that? Well, let's get down to morphology. Why do we look different? Environment plays a key role in basically how we look, the diet that we have, even our reproductive strategies. And I always liken humans to the naked mole rats of the animal kingdom. You know what I'm saying? It's because we're hairless, basically. Well, most of us. You should see my relatives in Scotland. However, because we're so hairless, we are vulnerable to the elements. And as we were evolving in equatorial Africa 200,000 years ago, we were getting pummeled by ultraviolet light, which is great for vitamin D production. However, too much ultraviolet light can basically destroy and degrade DNA, and also interrupt the production of folate, which is important for reproductive health. So because the body is an amazing thing, we adapted to produce more melanin, and melanin is what gives us the pigmentation in our skin. And when you had more melanin, it actually acted as a sunscreen that protected the skin and the DNA from degradation. So as we evolved, and humans are really funny, we like to move around a lot. I mean, we're actually the most dispersed primate on the planet. The second most is macaques. They're everywhere. Because they're like us, they can thrive in any sort of environment. But we're everywhere, and as we moved more north into the northern latitudes, you can see it's cooler, more blue, more greens. We basically had a lot less UV ultraviolet light, and so we had to adapt. And that meant we, over time, had a decreased melanin production. And so you see people looking like this guy. And if you notice that Neanderthal has kind of a impressive schnoz, that also is an adaptation to climate as well. So researchers have found that nose shape is oftentimes a response to the environment. They found that people in colder and drier climates had narrow navel cavities and higher navel cavities, and this was because as air comes in, it has more time and tighter space to get warmed up, so when it reaches your lungs, it's nice and warm because you're in a cool climate. You gotta thermoregulate, you wanna stay warm. So that's another example of how climate and environment plays a huge role in how we look. There's this idea that the cooler climates, the higher you go in latitude, that the body actually adapts. The trunks are a little bit thicker, the limbs are shorter to help keep in heat and warmth. The closer to the equator you get more gracile build, longer, leaner, longer limbs. This is an example of men in East Africa, the Maasai. You can tell they're all obviously tall, lean, long-limbed. And then you've got people, this is my father. He's Scottish. You've got somebody who's a little stockier of build, shorter legs, got tree trunks for legs. Not so different as far as wardrobe, honestly. I think he's wearing a toga and a skirt in both pictures. It's a kilt. But so that's an example of how environment plays a role in how we look. Another way we've tried to lump people into boxes is geography. We'll talk about Africans, Asians, South Americans. But that also is a little too generalized. If you think about it, Africa is a huge, huge continent. Would you lump people from North Africa, Moroccans, in with Ethiopians, in with Somalians, in with those from Congo? No, it's way too broad of a generalization. So basically what I'm trying to say is stop trying to put people in boxes using science and realize that according to science, there is only one race, and it's the human race. And now they're seeing that basically children are not born prejudiced. We learn this over time. So this is an excellent time that science can get out there and teach children from very young age that we're more similar than we are dissimilar. And the things that make us dissimilar, our morphology, is just responses to environmental pressures. So it's just our awesome bodies learning to adapt. So I challenge everybody to not try to be colorblind, because honestly, I kind of like the fact that we don't all look alike. That would be really boring, honestly. I know it's dark out there, but if you can, just look around to the people next to you or near you. It doesn't have to be, but just look around for 1 second. Maybe lock eyes. I don't think anyone here bites. And just think for 1 second, if you will, that you guys have a common ancestor. We all have a common ancestor. And at the core of it, we're all related. We are one big family. And so, be excellent to one another. Thank you.
Karen Bondar, Dr. Karen Bondar, is a biologist. She's written a book, The Nature of Sex. It's her second book. She also has a web series called Wild Sex. She's been on the Discovery Channel and Outrageous Acts of Science, and she definitely has sex on the brain. So she's going to talk to us a bit about animal sex.
The video that you just saw, yeah, let's talk about that for a second. The good news ends there. And that is because in the animal kingdom, sex really, for the most part, isn't fun at all. Biologists like to talk about this thing called biological fitness. We like to ascribe to all animals that they're aiming to maximize their genetic representation in future generations, i.e. their biological fitness. Okay, so that's all well and good. Males do it, females do it. But now, think about the difference in value between the sexual cells, or the gametes, between males and females. Where's Julian? Julian, yes. Conceivably, pun very much intended, you could impregnate every single woman in this room with the contents of one ejaculate, if we could scientifically make that happen, within one ejaculate, a male has about 70 million sperm. But you don't even need to just do it once, Julian. I mean, you could take your time and, take each lady individually and make it special and whatever. But the point is, even after he has impregnated all of us, he could still go for more. That's because sperm is abundant and cheap. It is the cheapest currency in the animal kingdom, that's sperm. Now, let's take it back to the females then. I have a finite number of eggs, and I drop one of those eggs once a month. And if that egg happens to be fertilized, I am out of reproductive commission for a further 9 months, and then potentially a few more before ovulation begins again. And what this means, biologically speaking, is that I need to be very careful and very choosy about whom I am going to allow to deposit sperm in my sperm bank. And this is, generally speaking, the way it goes in the animal kingdom. So a female needs to be very, very choosy, and a male just needs to try to get laid whenever he can. And, if you think peacock, like I like to be, I actually dress like a male peacock because it's the males that are beautiful, and it's the females that need to choose them. Now, what happens if a female has already received enough sperm, or has the ability to store sperm, and simply doesn't want any more? She wants to spend her time on other biologically relevant activities, taking care of offspring, finding food, avoiding predators. This is bad news for any male who has yet to make a deposit in her sperm bank, and essentially sets the scene for a battle between the sexes. Unfortunately, guys, sex in the animal kingdom is more often about conflict than it is about love. So I thought what I would do this evening is take a few moments to talk about the top 5 most horrible sex acts in the animal kingdom, because guys, we've got it good. Really, really, really good. In light of the fact that it's also nearing Halloween, we're talking about creepy crawlies, we're talking about animals that sort of, we think maybe are a little bit gross or maybe a little bit scary. I decided to sort of use invertebrates as my muse for the talk tonight. Now, this is a very innocuous garden snail, Limnaea stagnalis. You probably had them in your gardens. Limnaea individuals are what we call hermaphroditic. They are both male and female at the same time. Now, they are not simultaneous hermaphrodites, and that means it's better for a hermaphrodite. If you think about this conflict between males and females, well, when is that conflict more intense than within one individual? It's better for a hermaphrodite male to get in there more than the female, because the female role is a lot more energetically expensive. So if a hermaphrodite can be more and more male, well, that makes sense. So there's these wonderful little things called love darts. And far from being a Cupid's arrow, bing, love darts are actually weapons. Now, they're not the genitals of the organisms here in particular. Let me just show you what I mean. The love dart of something like Limnaea stagnalis looks like this. It's a weapon. It's something that is actually used during the sexual act to stab the partner, and it somewhat subdues the partner. And actually, the stabbing comes along with a dose of chemicals that actually cause that receiving partner to become refractory or uninterested in sex. And this is, biologically amazing. Can you even imagine that when I stab you with my love dart, what I'm actually doing is saying, stop having sex now, because you got my sperm. And that's all the sperm that you need, because my sperm should be the one to father all of the babies that we can make out of those eggs in your body. So this is something that's, more than a little horrifying, and you can see, morphologically speaking, these things take on a lot of different forms. But the main function is always the same, and it is to simply wound your partner. Now, has anybody here ever seen tiger slugs or land slugs having sex? Yeah, cool, I see a few hands. It is amazing. It is something that lasts for a number of hours, up to 7. And these guys are what we call simultaneous hermaphrodites. So it's really actually quite harmonious. It's not violent at all. These guys are in complete agreement with each other. They're both playing the male role, and they're both playing the female role. They're giving and receiving at the same time. So two partners in an incredibly complicated and wonderful dance and courtship ritual will find each other and then ascend up a tree or a pole or something. I've even seen them hanging from windows. And once they get to a certain height, they will then start intertwining their own bodies, as you can see here, and they will actually suspend themselves on a long, twisted mass of mucus. So they're hanging there, they're having, very, very complicated courtship rituals, they're twisting around in this beautiful pearly-like shape on the bottom. Anybody, any guesses? That's the penises. So the penises are actually very large, and they're extruded, and you can see they start winding around each other, and they will then find the genital opening of the partner in order to deposit the sperm. But those are the penises. And so you're thinking, well, hey, Dr. Bondar, this isn't horrifying, this is actually quite lovely. They found each other, they're hanging around, it's cool, it's, agreeable. The unfortunate part about this mating ritual is that the penises can often get so intertwined that they are unable to come apart. And so what happens is a delightful process called afophilation, where the individuals will actually nibble off the penis of their partner in order to get free. It's almost as though you're encased in all of these chains, and the only thing you can do is bite off the dick of your partner in order to free yourself from their wrath of cuddling. Once you have had your penis nibbled off, you unfortunately are now only a female, and this is something that happens quite frequently. It was lovely for a while. What you might not know about the animal kingdom is that necrophilia happens all the time. It's actually really, really frequent, especially in birds. There's possibly a few reasons for this. In fact, a lot of times sexual coercion is the rule, which means rape, basically. And females will assume a very submissive posture just to appease their male partners. And so males might actually just get it wrong and actually be copulating with a dead body of a female they might just not even know. Could be a mistake, because it happens all the time in many, many species. However, in the past year, biologists have found something really, really interesting with these Amazonian green frogs. These guys engage in a sexual behavior called explosive breeding. Again, you're probably going, wow, it's so good to be human. Explosive breeding happens in a lot of amphibian species, and basically the breeding season is very short. And a lot of these populations, these green frogs included, the sex ratios are biased. There's more males than there are females. So of course, this sets the scene for something pretty crazy, explosive, if you will. There's basically massive orgies of frogs in ponds of fresh water. Females often are asphyxiated or they simply drown. It just basically sucks to be female if you're an explosive breeder and the sex ratio is biased against you. So females often die. And what biologists realized, or what they observed, is that males will actually go to dead, deceased females and use their own bodies to pump the eggs out of the female's system and then fertilize them. So instead of being necrophilia like a mistake, like, oh, whoops, I'm sorry, you're dead, this is actually a biologically relevant thing that they're doing to increase the biological fitness of both themselves and the dead female partner. So make no mistake about it, functional necrophilia can actually be beneficial to the female in a weird sort of way, in that after the fact that she's already dead, she can still realize an increased biological fitness. So I've talked about love darts. I know, right? I've talked about love darts, but I saved the big stabbing for this one. A lot of times, guys, it's the actual penis that is the sword. There's a spider called Harpedica sadistica because of the nature of the stabbing. So a lot of times these penises, this is actually called traumatic insemination. That's actually what it's called in the biological literature, because the insemination, the act of insemination is actually traumatic, because most of the time, males that have stabby penises are not stabbing the female anywhere near her genital opening. No, they're simply stabbing her anywhere they can, and the sperm migrates through her hemolymph to her ovaries. It's a weapon, a big one. So what scientists discovered with another one of our gastropods, and I know I'm being gastropod friendly in this lecture, but I love gastropods, and I especially love nudibranchs. I mean, who doesn't, right? Okay, good, thank you. This is two nudibranch individuals. These are sea slugs. They are basically slugs that live in the ocean. They are, again, hermaphroditic individuals. So both are male and both are female, but they are not simultaneous hermaphrodites, and the one who gets to be the boy is the one that gets their stabby penis in first. And here's something really interesting that scientists noticed about the specific sex being had by this Cyphopteran species. The penis stabbing would occur to a great degree of precision and accuracy directly into the female's forehead. The same spot all the time. Stabbing her in the head. It gives a whole new meaning to the phrase, "Not tonight, honey, I have a headache." It's actually something that happens all the time. And what scientists realized is that not only is he stabbing his sperm directly onto the female's forehead, he's actually stabbing another set of chemical compounds that serve to increase the femaleness of the receiving partner. In other words, I will stab you in the head, and I will drop a bunch of chemicals on your brain to make you not want to be a boy anymore, to make you want to be a girl. Now, this story is still unfolding. It's incredibly complicated, as you can imagine, but wow, there's so many times in my career and in the course of writing about these things that I just have to step back and think about the process of evolution and think about the ways in which evolutionary biology is echoed in sex and just be in awe of all of these wonderful things. Now, this brings us to number one. And I'm going to have my friend Julian come up here. I brought along with me a spider because, you know, spiders have some of the most traumatic, gory, ridiculous sex out there. And so this female, now we have to keep in mind this is not necessarily a biologically relevant pairing because Julian, as the male, in many of these species would be much, much smaller than the female. But this is the biggest one I could find, so bear with me. We're going to talk about two spider scenarios here. First of all, one that's, well, I'm not going to say one favors the male over the female. These are your penises. Spider males have two penises, or pedipalps, and these are the appendages that males use to transfer sperm to the female. Now, male Todaran spiders have really, really big pedipalps for their body size. So this is not a sexually cannibalistic species, but what biologists noticed about, nice, well done, about male Todaran spiders is that their pedipalps made it really tough for them to get around. Imagine having to lug, it takes a lot of energy. Imagine having to lug around penises that are bigger than your own legs. That's basically what the scenario we're dealing with is here. Why would evolution favor such a strange adaptation? What could be the advantage of male Todarans having these preposterously big genitals? What the males do, once they've found an appropriate female partner, this is your female partner, we'll call her Betty. Once males have found an appropriate female partner, they start to twist those pedipalps. They twist them, and they twist them, and they twist them, until they pop right off. And they then use those pedipalps to stab into the genital openings of their female partners. Look at poor Betty. Okay, well, let's imagine that one stayed. There's two functions that have been accomplished here. In emasculating himself, the male has plugged up Betty, and this means that no other males can get into her genitals because they're blocked up by his dismembered penises. This serves as a mating plug, and that's one of the main functions. But the other main function, in Todarans specifically, is that now that he's free of his massive genitals, he can actually guard her to a way bigger degree, and he can make sure that no other males get a chance to mate with her. Sure, his future reproductive success depends on the fact that no other males can get in there So he uses his newfound energy to guard her against other males. Well done. Well done. Now, the number one for tonight is going to be a reverse scenario, because a lot of spider species are sexually cannibalistic. There's probably no kink quite as severe as feasting on your partner after you've had sex with them. But what if you've never even had a chance to have sex with them? There's a certain species of wolf spiders where when females are actually sexually satiated, in other words, they have enough sperm, what they will do is they will secrete a substance over their genital plate that transforms them into a spider-sized sticky trap, so that unsuspecting males that come along and try to mate with her, with their pedipalps that are normal-sized, get stuck. And they can't move, and they can't move, and she's got them, and she eats him. And he dies. And he gets eaten. So the female spiders, well done, man. The female spiders that make themselves into sticky traps are perhaps my number one. Can you imagine? You're trying to court somebody, you're trying to, hey girl, how's it going? And you can't get away, and then she eats you. That's my unfortunate number one, most horrifying sex act in the animal kingdom. I will otherwise thank you so much for your attention. It's been so wonderful and a pleasure to be here tonight. Thank you for listening.
When you're young, you do get to be afraid of the dark. Sometimes that lasts into adulthood, as the video just said, but hopefully you get a little smarter about it. When I was a kid, I was afraid of aliens coming into my house and kidnapping me because my dad was a big fan of 50s aliens films like Day of the Triffids. Anybody seen that one? Yeah, it's awesome. Not when you're like 7. So I thought aliens were gonna come into my room and, kill me or kidnap me or whatever. So I would hide under my blankets. Because, you fly 1,000,000 miles, he's under the blanket, I can't see him. When it comes to the dark, it's not necessarily the aliens that you're afraid of. It's the refrigerator starting, and you don't know what that is. It's the sounds that come in the night. It's the things that go bump in the night, not the things so much as the bumps themselves, right? Coming up next, Dr. Joe Hansen, biologist, host of It's Okay to Be Smart on PBS Digital Studios Online as well. They lent him to us for the night, which is great. He's going to come up. He's a public speaker, snazzy dresser, and he's going to talk a little bit about those things, the bumps, not the things, the bumps.
Psychologists classically classify emotions in 6 categories: happiness, sadness, surprise, anger, disgust, and of course, pizza. Just kidding. It's fear. But when most of us think of what scares us, a picture enters our minds, something that we see. But it turns out that what we find creepy to look at is actually pretty subjective. I mean, for instance, some people are like super big fans of clowns. Those people are weird, but they do exist. But what about sounds? The sounds that scare us. These are far more universal. They're wired into our brains. They're rooted in our very evolution. Most of us don't pay much attention to sound every day. We kind of go through our lives. And that's probably a good thing. Because this is what many of us are surrounded by on a daily basis. We're walking down the sidewalk, and if our brains didn't filter this and put it in the background of our consciousness, then we would go crazy. We would completely lose our minds. And in fact, most of our relationship with sound happens under the radar of our awareness. And tonight I want to unlock a bit of this for you and introduce you to some people who use this as a dark art. It's just how sound waves, fluctuations in air pressure can be used to invoke sheer terror, and how, hold on a second. Hey, it's Julia from D News. I'm trying to do a thing up here. What are you doing?
Trying to scare you?
Here, you want this? Where'd that come from? That's weird. You're trying to scare me. You're not doing a very good job, I have to be honest.
Well, your face is already the scariest thing in here.
Wow, sick burn, Julia.
What? What are you gonna do about it?
Well, I guess since you're already here, you wanna join me and talk about some scary sounds?
Yeah, might as well.
Cool, grab that thing. Let's go over here. Round of applause for Julia, everybody. So Julia, if you wanted to scare me, I have to say there's a much easier way.
Oh, really?
Yeah, so what do you think the fastest nerve impulse in your body is?
When I go to grab my coffee in the morning?
That's a very good guess, but not correct. See, most nerve impulses in your body are actually pretty slow, maybe like 60 miles an hour tops.
But our bodies aren't that big. That's still pretty fast.
Okay, sure. But let's say you walk up on something like this.
Oh,
Might not be fast enough.
no.
I'm just saying.
I mean, light has to enter my eyes, and then that goes to my visual center, and then the memory center in my brain is like, oh my god, that's a tiger. And then my motor
But-
cortex has to get me the hell out of there, and it's a whole...
Stop. You're like already tiger food. Too late. We have something called the acoustic startle reflex. Anytime our ears detect a super loud and sudden noise, the nerve impulse actually bypasses your conscious brain, goes directly to your limbs and muscles, and you actually jump before you even realize that you've heard something. Like, it's the fastest thought there is.
Yeah, and since like our ears are right next to our brains, the nerve impulse doesn't have as far to travel.
Yes, exactly. The only thing takes like 50 milliseconds.
Yeah, the blink of an eye.
Actually, technically speaking, a blink is 150 milliseconds, but I'm just saying.
Such a smart ass. But that makes sense. I mean, in general, nature is trying to kill you. You snooze, you'll lose. What about the other ways media scares us with like music?
Right. Scary movies. What was the last scary movie you saw?
Ooh, I don't know.
I love the old ones, like Halloween,
Good
like
one,
classic scary soundtracks, right? So there's a neuroscientist named Talma Hendler, and she says that music is actually a really sort of abstract emotional carrier, and it can take these subjective emotional experiences and manipulate them with any sort of meaning. And Hollywood is really good at manipulating us.
Oh, yeah.
All right, unlock this door. Do you hear me? Unlock this door, I'm gonna shoot through the door.
Don't do that.
So tense.
Oh my God. This is always...
Can't watch.
Oh, okay, I guess we don't... What do you think happened to him?
He probably died.
Yeah, probably died.
Yeah, and music in those situations like tells us something bad is gonna happen, but the character doesn't know. And that tension is what keeps us on the edge of our seats. But it's not just those like high trilly notes either, even low notes can sound creepy.
I'm really starting to get creeped out, I gotta be honest.
Okay. So that makes me feel scared, but why do sounds make us feel that way?
Excellent question. To answer that, though, I'm gonna have to introduce you to a different scary sound. Now, warning, this is one that makes some people shiver. The hair on the back of your neck might stand up. Some of you might even feel the urge to run out of the exits. Please do not. It might be unsafe. Wow.
Yeah, frightening. But what does that have to do with horror movie music?
Well, crying babies are another example of a sound that evolution has programmed us in a way not to ignore as much as we would like to sometimes, I think.
Because a crying baby is like a sign of distress, that something is in danger. That makes sense, but I don't hear like a bunch of crying babies when I watch horror movies.
We are clearly not watching the right horror movies.
What ones are you watching?
Okay. I can explain this to you. Do you happen to have a violin on you?
No.
Don't worry about it. I brought one. Everybody, I'd like to introduce a special guest, Caitlin Hova, who happens to have a violin.
Ow!
I always keep one around. You really should. Caitlin, do you think you could play something sort of nice and happy for us?
Oh, that's
Nice.
so nice.
I really like that.
Aw, thank you.
So think about what we're hearing. We're hearing pretty little notes. They're in nice even ratios. There's not a lot of dissonance, but the instrument is playing within the range that it was designed to be played in.
Right, so the violin's happy, so we're happy.
Yes, and now Kaylin is going to play something a little less happy.
Ooh, yeah,
I think we all recognize that one.
yeah. And there's like a lot of harsh tones going on, bad harmonics. The instrument is playing way out of the range it normally does.
Yeah, it's a little chaotic. So scientists call these non-linear sounds. They're irregular. They've got a lot of weird stuff happening. They're
Basically
chaos.
noisy, right?
Yes, basically noise. And they happen when the instrument that's used to make them, whatever that might be, is pushed beyond its limits. Have you ever seen a marmot?
Yes?
That's a marmot. Aren't they cute?
Okay.
Have you ever heard a marmot?
Not recently.
Weird. Totally acoustic startle response taking effect. That's actually what a marmot sounds like. That's what fear sounds like if you're a marmot. And there's a researcher from UCLA named Daniel Bloomstein who spent a lot of time, maybe more than you would think healthy, listening to the alarm cries of marmots. And it turns out if you analyze the waveforms and the sounds and things like that, you see the same kind of things happening as you did with the Psycho shower scene.
So whether it's violins or vocal cords, the sound that gets pushed to its limits, that's when chaos sets in and it starts to sound freaky.
Yeah,
I guess fear is noisy.
you're catching on.
That's cool and sounds freaky, but it also tells marmots to like pay attention and feel afraid.
Right. I mean, to a marmot, it's like step one, hear the sound. Step two, GTFO, or you're going to get eaten. It's a really important signal for them.
Dang, evolution, you're scary, but kind of cute.
Very cute and fluffy.
Hey, Caitlin, can you do a marmot impression?
Freaky. All the marmots in the entire county just ran for their
fled.
lives. So Hollywood's actually
GT
taken a
to F or
lesson
whatever.
from not only marmots, but other species in order to kind of invoke fear. In Jurassic Park, by the way, nobody knows what it sounded like, but the sound designers, to invoke fear in the audience, because you all look terrified right now, they mixed a few sounds together. The first was the squeal of a baby elephant. Not that scary. The rumble of an alligator. Getting there. And the growl of a tiger. Put these together.
Ooh. All those animals are making sounds that like evolved to get noticed, to either announce fear or to invoke fear in other animals. And just like with human screams, like when their vocal cords are pushed beyond their limits, that is when all that noisy, non-linear stuff starts to happen.
The scary stuff. Animal screams inspiring human screams. And one final clip to share with you tonight. There's one movie that did this combination better than any other movie.
So well.
Nothing brings people together like birds trying to kill children. I heard there was an instrument invented for this movie. You should go look it up. It's called a Trautonium, one of the first synthesizers. For all you electronic music fans, you owe a great deal of gratitude to movies like The Birds. Caitlin, do you think you can do a crazy child-eating bird impression?
God.
I think it was pretty good. Round of applause. So, I mean, this is really cool. Sound holds a lot of power over us. You know, even if you're not aware of it in your conscious life. I guess you can't spell fear without ear, Julia.
There's the door.
Thank you guys. Thanks, Caitlin. Thanks, Julia. Sleep
Caitlin.
tight.
How many science enthusiasts do we have in the audience? Great, that's fantastic. That's exactly what we try and do at D News, is get people excited about science. We want people to look for questions and answers, and we also want to debunk certain expectations that people have of their science, pretty much like Natalia's talk earlier. We're taking something that people commonly believe, and we're trying to explain why maybe what their belief that they're holding it might not be quite accurate. A lot of people can call this as well pseudoscience. And there is a guy who kind of specializes in taking what we think we know about science and kind of tricking us, giving us an illusion of what he's showing us being real, when sometimes he's basically just debunking this pseudoscience for us. So my friend Brian Brushwood is going to come up here, and some call him a magician, or an illusionist if you want, but I call him a science illusionist, because what he does is he takes what we think we know and he just twists it just a little bit, because our senses can fool us pretty easily. So Brian, come on up here.
Howdy, folks. My name is Brian Brushwood. I host a little show on the internet called Scam School. We call it the show about social engineering at the bar and on the street, which is a fancy way of saying we teach you how to use science and trickery to screw your friends out of free beers. I want to talk a little bit about the idea of pseudoscience and the paranormal here. I'm going to give you two presentations of things that at one point might have felt like fringe science or slightly supernatural. I'm going to walk forward with a bed of nails and let you guys in on the inside here. I actually want you to reach forward here because there's something very deeply visceral about actually touching a bed of nails. For those of you guys who don't know, bed of nails is a very, very old effect dating back centuries ago. East Indian Hindu fakirs would claim that they would put themselves into deep hypnotic trance that allowed them to actually stop their hearts in order to keep themselves from bleeding. That's a bunch of But however, the bed of nails is based on a very simple principle, one that says, as long as you have a sufficient number of nails, the weight of the body is spread out evenly over all of them, and as a result, no one nail can actually penetrate the body. Now, having said that, there is a lot that can and does go very, very wrong when performing the bed of nails, and to that extent, allow me to elucidate. First of all, if the performer lays down too quickly upon the bed of nails, or if too much weight is placed upon him, he will immediately be pierced, damaging internal organs and causing a very bad day. Now, the amazing thing is that if you go to the emergency room with this type of wound, they'll basically put Band-Aids over each of the holes, they'll give you an antibiotic shot, and they'll send you on your way. The bad thing happens when the performer begins to panic while he's on the bed of nails and shift his weight foolishly. When he does, he'll end up with what's called a compound laceration. In this case, the flesh is actually ripped off of your back, causing extreme damage, and there's no way around it. You're going to get horrible, horrible scarring. So in other words, while it's very unlikely I will die doing the bed of nails, you could get to see some blood, which none of you guys are impressed by. That's great. At this point, I'm going to have Trace walk out into the audience. I'm going to have him pick out a couple of volunteers to join me up here on stage while I prepare myself to face the bed of nails. People are like, I don't know what it is, but I'm volunteering. It's always the guys. You guys just hang out right over here on the side. Now, here's the thing. Regardless of whether it's performed as a religious ritual or as a sideshow stunt, it always begins the same way. The performer always begins by taking a moment to center himself before laying on the bed of nails. As I mentioned, Hindu fakirs talked about going into a trance. That's a bunch of nonsense. What's really happening is that the performer's taking just a moment to make sure that they don't do anything stupid while they're in the position of very real danger. The performer then begins by centering his weight over the bed of nails, first laying down the covered extremities until finally his entire body is suspended on the bed of nails. Now, the ancient Hindu fakirs did not stop here, but rather subjected themselves to certain tests while they're in this state. To that extent, I've asked these two women to join me on stage because in just a moment, both of them are going to stand on me. Hi there, my name is Brian. What is your name? Melissa, and you are? Kristen. Excellent. First of all, let me get both of you guys to get your feet all the way touching up at the bed of nails. First of all, you'll notice that Trace is there in between you. Each of you guys, I want you to put one arm on Trace's shoulders, okay? Kristen, in just a moment, you're going to put your right foot right here on my chest, not on my neck, on my chest, okay? Your left foot, in a moment, will go right here on my belly button. Melissa, right? Melissa, your right foot is going to go slightly below the belt. And your left foot is going to go on my thighs. Now try to distribute the weight evenly because otherwise it hurts like hell. Any questions so far?
Nice and slow.
All right,
Okay.
feel free
Nice
to keep
and
your,
slow.
go ahead and lean on Trace at all times. When you step up, you're not going to hop up, you're not going to bound up. You're going to put nice even pressure with one foot, then bring the
This is
other one up.
science.
And then, when I excuse you to step down, this is the most important part. You're going to look down where you are stepping. You're not going to hop off. You instead are going to look down, move slowly and in control at all times. And as you step down, make sure you're stepping onto stage, because if you were to step on the nails, you will
That would be bad.
injure your
That would
feet, right?
be bad.
Any questions? Are you ready to do this?
Excited? You good? Slow and steady. Slow and steady. Ready?
All right, so here, let's get your right feet in position first. So we'll go ahead and set this right about here. Nice. Get this right about here. All right, we're gonna go slow and in control at all times. On the count of 3, nice and easy. Ready? 1, 2, 3. Nice and easy. All the way up. All the way up. All the way up. You may applaud now.
Okay. Stay there.
You can get off of me
Okay,
now.
slowly down. Back down.
All right, nice and easy. Take a big step back, and let's have a huge round of applause for both of our volunteers.
Thank
you guys
so
did
much.
a fantastic job. Trace, get on over here. Let's get you right up front. There we go.
Ready?
Ready? 1, 2, 3, all the way up. There we go. Hey, make some noise.
Thank you. Thank you.
By a round of applause, how many of you guys can see those divots on my back right now? How many of you guys can see those?
Whoa.
Make noise. Yeah, those are actually not puncture wounds. The skin has phenomenal tensile strength, and those are actually parts of the skin. Wow, I just kind of want to stare at my back now. Those are parts of the skin that have been stretched so hard that it's left a temporary divot that'll stick around for as many as 20 or 30 minutes after the show is over. And the red welts caused by the stress will stick around for as many as 6 or 7 hours after the show. So if while we're hanging out after the show, by the way, I hope I get to meet all you guys, but if while we're hanging out, if one of you guys walk up and you're like, hey bro, take off your shirt, it's cool. I mean, so you can see the, right. Okay, let me get these taken all the way off stage. And at this point, I need someone from the audience who's willing to do absolutely anything. Who am I looking for? Actually, right there, third row. What's your name, buddy? Stand up. What's your name?
Oh, Michael. PBS Michael.
Wait, do we know Michael?
No.
Oh, screw it. We'll use
We
Michael
called
anyway.
him out
Everyone make
earlier.
noise for Michael as he comes up here on stage. Michael, we're going to have a little bit of a demonstration of something that was extremely popular in the 1970s. It was a process called psychic surgery. The people who did it
Right up
performed
this way.
or claimed that they could cure any ailment, whether it was cancer, whether it was leukemia, whatever was wrong with you, they could fix it by actually reaching inside your body and pulling out tumors. Now, we're not going to do that because we're not a bunch. So instead, we're going to do a card trick that looks an awful lot like psychic surgery. Being a good card trick, we're going to start off with a regular deck of cards. I want you to verify all the cards are different, everything right. No fake deck. Do me a favor, reach forward, extend one finger, buddy, touch the back of any one card. It does not matter which one. Take that card. Do not let me see it. Show it to the audience, however. You got it? Excellent. What did you say your name was? Michael, I want you to take this Sharpie marker. I want you to print your name nice and neat in the center of that card. Let me know once you're finished. Neatness counts, and by all means, take your time. Here's the problem, Michael. Every single card trick is exactly the same. Every card trick has 4 fundamental principles. You have to have a card selected, identified, lost, and then found. You've already had a card selected. You've printed your name on it so it's clearly identified. I want you to fold it in half with your name on the inside and then fold it in half a second time so you fold it into quarters. Let me know once you've done that, Michael. Excellent. Now, Michael, this is the part where we lose your card. Now, normally, magicians will lose your card by shuffling it into a deck. However, we, my friend, are going to be much, much more thorough. I'm going to use this enchanted magic wand that if you are the kind of person who believes in magic, you are seeing your card vanish into a magical puff of plasma. And if you're not that kind of person, you're seeing a fire code violation in a historic theater. There we go. Excellent. All right, now at this point, it looks an awful lot like your card is vanishing right there in front of your eyes. So at this point, I'm going to take the ashes and I'm going to chop them up because it's still right. I mean, it's just transformed, but the ashes are right there in front of you. Now we get to the most important question of the evening. Michael, do you prefer chocolate pudding or applesauce? You're going to go with applesauce? I did not pick you for an applesauce guy. All right, here we go. We're going to take some applesauce. Perfect. That's lovely. All right, I'm going to mix this up. All right, now I want you to see this is not some kind of switcheroo, fake ashes switch, which would be dumb. Do me a favor, Michael. Just taste that. Just taste that. Tastes fine, right? Yeah, all right. Do me a favor. I want you to polish that off, Michael. Something amazing is going to happen. The faster you eat that, the louder they'll cheer for you. Watch for it. Go, 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 go.
Michael, 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 Michael.
Told you, right? There we go. All right, Michael, at this point, we have 3 phases down. We had a card selected, identified, and I would say extremely thoroughly lost. I think we could agree that it would be extraordinarily difficult for me to retrieve your card. Michael, I need you to come on over here. I want you to plant your butt right here in the middle of this table. I want you to put your head down at this end, your feet down at that end, which sort of happens by default. There we go. And then, Michael, I want you to, go ahead and lay down, put your head right on there. You got it, you got it, you got it. Take a deep breath in. Pull your shirt all the way up to the top of your chest. Pull this up as well. Oh, hello, ladies. All right. No, quit flexing. Stop flexing. Relax, relax, relax. Relax, relax, relax. There we go. We're going to take this right here. All right, now this, I apologize, Michael, this part's gonna feel just a little bit weird. I gotta cool, it's cold water. It's clearly cold water. All right, here we go, relax, 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 relax. All right, here we go. A little bit of psychic surgery. There we go, all right. Now at this point, were I an unscrupulous psychic surgeon, I would be telling you that I'm pulling tumors out of your body, but I'm not, so I'm going to say these are tumors coming out of your body. Oh, yeah, no, you're fine. This, yeah. Yeah, actually, I think that goes there. All right, that's, hold on. Yeah, there we go. Well, that's weird. How did that get in there? Oh, no, wait, Michael, if you look inside the balloon, Michael, if you look inside the balloon, you'll see an object inside there. Do me a favor, hold out your hand. I just want you to pinch that side right there. I'm gonna cut that off. There we go, that's yours to keep. Inside, we have a card way back at the beginning, back when we were doing the card trick. Michael, what was the card you got? The 2 of clubs. Would you verify? Is that the 2 of clubs? Second of all, you printed your name right in the middle. Would you verify? Is that your name in the middle of the card? Yes, let's have a huge round of applause for Michael. He did a fantastic job. There you go, buddy. Here, get on up nice and gentle. I'll get you back as well. Pretty sure that washes out. I've never stuck around in the same city long enough to find out, though. One more time for Michael, ladies and gentlemen. My name is Brian Brushwood. Let's hear it one more time for Trace, who is absolutely slaying it this evening.
So I want to thank all of our performers tonight, all of our presenters. Guys, come up here, take a bow for everybody. Thank you to everyone for coming out tonight. We did this for you. We continue to do this for you. And we love you for it. So thank you so much for coming to our very first live show. 1, 2, 3. And as we always say at the end of D News, we'll see you next time, and more research is needed. Thank you for watching.